Assalamualaikum to my panel, Dr. Nur Hafiz bin Salim and Dr. Nuzawani binti Saharuddin. My name is Nur Helmi bin Nur Azri and thanks to Dr. Muhammad Fani as a supervisor that guided me through this project. My research title is Optimal Load Management Strategy among Residential Consumer in South Peninsular Malaysia. The presentation is divided into introduction, literature review, methodology, and lastly, result and analysis. Okay, let's start with the problem statement. In Malaysia, there is only one tariff that being offered to residential houses. Although the improvement of old meter into smart meter, the owner can only monitoring the consumption and cannot apply the demand response program that has more energy efficient. The tiered flat rate tariff that can be used today make the energy consumption and electricity bill increase, especially during MCO where all residents are prefer to stay at home. There are three main objectives from this research. First, we are analyze the behavior of different type of load profile toward the TOU tariff design. Second, we are investigate the energy reduction that consumer need to apply before changing into TOU tariff. Lastly, to analyze the cost reduction that can consumer enjoy by shifting the load by using N colony optimization algorithm. In this chapter, I am discussing the previous study of related topics such as demand side management, demand response, price-based program, time of use, advanced monitoring infrastructure, and N colony optimization algorithm. AMI is basically a smart power meter. As you can see, the main equipment to use TOU tariff is by installing a smart power meter. The important parameter that can be monitored is energy consumption of 24 hours load profile. Demand response is the change of consumer energy consumption to match with the energy utility supply. It has done to reduce the CO2 emission and reduce the overgeneration from energy utility. To achieve win-win situation for both consumer and energy supplier, the demand response program such as TOU is proposed. The consumer will enjoy the low of peak price, while the supplier will help reducing overgeneration and able to reduce CO2 emission. TOU is under price-based program, while flat tariff is under incentive program. To reduce the electricity bill in TOU tariff, the demand side management technique such as load shifting is needed. Load shifting is basically shifting the energy consumption at on-peak zone into off-peak zone. By this, the higher cost per kilowatt hour can be slightly avoided. The optimization algorithm is needed to find the optimal cost and load profile. So, in this research, SEO algorithm is applied to find the percentage of energy or cost reduction that can this algorithm propose. As you can see in this table, it shows that other algorithm that contribute in electricity cost reduction. The result is between 5.44% until 11.2% of cost reduction. The equipment or software needed in this research is laptop or computer, MATLAB software, and MultiMB account to download the energy consumption data from different houses. This is the overall flowchart for this research. I will discuss more on SEO implementation process for this research. The SEO process is starting by initialize the parameter such as pheromone factor with shifting percentage and 24 hours load profile. Next, the end is generate global random load profile to find which profile is the best term of cost reduction. Next, the latest TOU cost is present. After that, the end is gather and update the latest trail to another end. The process is repeated into the next iteration until 500 iteration. The end will reach convergence when there is no more best trail to achieve best cost reduction. Lastly, the most experienced end will present the best shifted load profile. Another data that can be obtained through MATLAB is cost and energy reduction. To make the result more interesting, a case study is made by simulating 6 different TOU time zone design from different countries. Case 1 is declared as a baseline and the TOU price is applied to all cases to compare the performance of time zone of another country. The simulation is run by setting the load shifting weightage from 5% until maximum 30% to each type of houses. This is the time zone design for case 1 until case 6. The on-peak time usually 4 hours until 7 hours depend on the country. The longer off-peak zone, the more potential in cost reduction. The time partition from this case is 2, 3 or 5 partition. The different partition will give the different formulation. This is the summary of best load shifting setting to achieve the best cost reduction. Majority is in 30% setting, but as you can see, sometimes 25%, 20% and 15% also give the best cost reduction. After all 180 simulation, this is the best load profile that has been proposed by the SEO in terms of cost and low energy reduction. Usually, the data is shifted at 12 am until 6 am. The profile is usually reduced at on-peak zone. This is the result for single-story, double-story, and apartment houses. For large energy consumption load profile such as semi-detached and bungalow houses, the pattern behavior is same by shifting the high energy into 12 am until 6 am and reducing at on-peak time. And this is the compilation of all best load profile for each houses. The pattern in increasing and reducing form is same as before. To verify the stability of the SEO algorithm, the end fitness pattern is analyzed from different LS setting and house. As you can see, for low energy consumption low profile, the result of below 20% setting is not stable because the result is reaching convergence too fast. Overall, the end fitness result is stable. To enjoy the cost saving, the consumer also need to reduce some of the energy consumption. Based on the table, only case 1 gives the stable result from each type of house. The average energy reduction is only 13.24% compared to other. So the consumer only take less effort to enjoy the cost saving. The average percentage cost reduction result for all houses is nearly same. Although the higher percentage is case 4, but the energy reduction for case 4 is the highest. So, case 1 is chosen because it has low energy reduction effort and quite high cost saving at average 18.12%. So, I can conclude that case 1 is the best result because it has low energy reduction and high cost reduction. The result given also is stable for all types of houses in case 1. And the worst case is case 4 due to the high energy reduction effort that consumer need to do. The uniqueness of the research is I am revealing the energy reduction percentage because another researcher do not include the energy reduction percentage in their paper. For future recommendation, this TOU design can be enhanced by varying the suitable and affordable cost of on-peak and off-peak. So, consumer can enjoy more cost saving and the utility can offer TOU tariff to Malaysian residential. That's all from me. Thank you.